See, as I told you, there are the electrolysis, its industrial applications and its metallurgy applications are very immense, and it is more than what you think and more than what you predict. See, now we will go to the session 8.5, that is two more uses of electrolysis. We will see some of the uses of electrolysis. See, and for going into that, we will see how the electrolysis of copper sulfate in the presence of different electrodes, how it will be happening. For instance, you just check the condition. See, this is okay. So these are actually platinum electrode. Okay. And this is a copper sulfate solution. Okay, and see, now you will be connecting this to battery. Okay, so here it is anode, this is actually cathode. Okay, see, here in this example we are using platinum as the electrode. Platinum is actually an inert electrode. Do you know why? Because it only passes the charges. It only passes the positive charges. It doesn't allow the, it is not going to react when the electricity is passing. It is a very inert electrode. Okay, it only acts as a charge carrier. And now you are well aware that this is an aqueous solution, right? So this is an aqueous solution. Water also will be there. So in that situation, very well, water, it is going to dissociate into 2H plus plus OH minus. Sorry, not 2H, H plus plus OH minus. Copper sulfate, so this is going to dissociate into Cu2 plus plus SO4 2 minus. Okay, and then and H plus plus OH minus CuSO4, it is going to dissociate into Cu2 plus plus SO4 2 minus. Okay, so the anions are, so do you know what are the anions? Anions is supposed to be it is OH minus and SO4 2 minus, and the cations are H plus plus and Cu2 plus. Okay, and yeah, so the anions, if you check the container, anions, it will go to anode. So what are the ions it is going to anode? So it is going to be OH minus SO4 2 minus, and the cations, it will go to cathode. So what are the cations it will be going? H plus plus Cu2 plus. So this is going to be cations, this is going to be, and H plus and Cu2 plus, it will go to cathode. This is anode, and this one is this second one is cathode. Okay, and so this is the reality it is there. Here in the anode, H plus and Cu2 plus is there. Of course, Cu2 plus, if you can check the electrochemical series now. See, hydrogen, below the hydrogen, copper is coming. Obviously, copper will be depositing in the cathode. So, the cathode will have the deposition of copper. Okay. And in the anode, OH minus, it is actually, yeah, in the OH minus, like that is going to get discharged in the anode. So, 4 OH minus, so this is going to be, and this will release a 4 electron, and oxygen plus 2H2O. Okay, 2H2O, and so this is the reaction, this is going to be the one which is happening. Okay, so through the anode, okay, oxygen will be releasing, through the cathode, nothing will be releasing, copper will be discharging in the cathode. So this is what is happening. This is what is going to happen when platinum we will use as the electrode. Platinum is actually the inert electrode. Okay, And yeah, now if you check it, probably another aspect I can tell you. See, this is a solution of copper sulfate. You know the color of copper sulfate, right? I don't need to tell you. Copper sulfate is a blue in color. Okay, so that blue color copper sulfate solution, when the electrolysis happens, it is going to fade. Blue will be slowly. Blue will be slightly bluish. Nothing bluish, like that it will be coming. Okay, and so this is going to happen with the electrolysis of a copper sulfate solution. Okay, when we are using platinum as the electrode. Platinum is a counter electrode. Sorry, platinum is actually a inert electrode. Inert electrode means it doesn't, it is not going to react, it is not going to dissolve when the electricity is passing. So this is the products. So the products are oxygen in the anode and copper in the cathode, right? So if I write the reactions in the copper, in the cathode, okay, cathode half cell reaction, it could be and Cu2 plus 2 electron gives us Cu. Okay, and now let's see what will be the outcome. Instead of this platinum electrode, what will be the outcome if we are using copper as the electrode? Okay, we are going to see that. We are again the same situation. Okay, so here you are using see, this is copper anode. This is using copper cathode. Okay, so this is copper anode, this is going to be copper cathode. Okay, so this solution, let it be again copper sulfate solution. Okay, copper sulfate solution, and we shall see what is going to happen. See, here when the electricity is passing in the anode, like this copper anode, mostly we will take it as an impure anode. Okay, so this copper, it is not a inert electrode, it is a reactive electrode. So what should happen? See, when you are connecting to a battery, okay, so in the anode, this solution, this copper sulfate solution, you can see in the electrolyte also copper sulfate solution, anode also copper sulfate, and cathode also copper. So copper, in the anode, this is going to dissociate into Cu2 plus 2 electrode, and cathode. So cathode, what will happen now? This is Cu2 plus ions. What is going to dissociate into the electrolyte? See, this is going to dissociate into the electrolyte. This will go into, and this is going to go into copper cathode. So in the cathode, the Cu2 plus ions plus 2 electrons, this is going to become, this is going to get deposited in the cathode. So after some time, the size of this copper anode, it will shrink, but the size of copper cathode, this is going to increase. Okay, this is going to increase, and that is after some time, copper anode will be no longer there, copper cathode will be increasing its size. Okay, and so this is what is happening, and you can understand. I got a question here. See, copper sulfate is the electrolyte. You know very well copper sulfate, it is a blue in color, right? It is blue in color, and so what to say, the color of the copper sulfate solution, it is going to be blue in color. So after some time, when you are passing electricity, what shall happen? The color of the copper sulfate solution, it is going to be, it will remain the same, because how much amount of copper is going to the cathode, that much amount of copper is coming from the anode. Okay, so this is what is happening with the copper sulfate. This is going to what is happening with the shrinking of what is going to happen with the copper. Okay, the electrolysis of copper sulfate, solution in the presence of copper as the electrode, and so here, this electrode, what is in the anode, that itself is oxidizing. That is oxidizing because it is losing electron, right? So, and the same copper that is dissociated from the anode, that is the one it is getting deposited into the cathode. Okay. So different conditions, different electrodes, different products, different electrodes. So here the products are In the anode, you know, there is no product because it is only dissociating. Cathode, the main product is copper. So there is only one product here, that is copper. Okay. This particular aspect, you know, dissolution of copper, when you are using copper as the electrode, you know, that is going to, that is responsible for, that will give two applications. We will see what are those applications. Okay. One is electrorefining. Next one is electroplating. Okay, so electrorefining and electroplating. Here they will use impure copper. Impure copper as the anode, okay, and pure copper as the cathode. Okay, so here I will write pure copper as the cathode. Okay, same way previously, like the electrolyte, it is going to be copper sulfate. Okay, electrolyte is supposed to be copper sulfate. Of course, they will connect it to the battery. Okay, they will connect it to the battery. So, what will happen when the electricity is passing? Of course, you know very well that this is anode. This is a positively charged electrode. This is actually cathode. Okay, and in the anode, of course, you know very well what reaction it is happening in the anode. So this is a copper CO2 plus plus 2 electrons. Okay, and in the cathode, so it is actually Cu2 plus plus 2 electrons. It is going to be, okay, it is going to be actually this copper, it is going to get deposited in the cathode. So as the electricity passes, this copper, you know, this is going to dissolve, and okay, it is going to dissolve. So that will go into the solution, and in the cathode, you know, the copper deposition will be happening. The size of the copper, you know, that will get deposited in the cathode. Okay. Okay. So after some time, this anode size, it will shrink, and the size of the copper cathode, it will bigger. Okay. And where does the impurities it will go? This impurities from the from this anode, it will go and deposit in the bottom. So it will deposit in the bottom of the tank. We call it as anode mud. Actually, with some advertisements you will see. Okay, if you take 1 kilogram, half kilogram is free. If you take a 5 kilogram, this gold coin is free. Something like that. You know, there will be some free steps. It will be happening in the advertisements, right? So in the electrorefining of copper also, this is not a different situation, because in the electrolysis of copper, okay, you know, this copper electrode, when it is dissolving, this anode mud, it will be coming, right? Actually, anode mud also contains some of the elements. So for example, gold, silver, platinum, these kind of precious metals will be there in the anode mud. Actually, the cost of electrorefining will be met usually by the anode mud. Okay, because anode mud contain more precious metals than sometimes copper. So this is the reality happening. So you know, here actually the once after some time, as I told you, this size of the anode, it will be nothing, it will be very less. That time we will remove the anode and cathode together, and we will again put another cathode, another anode and another cathode. Okay, so this is how the electrorefining happens. It is one of the very excellent technique, because the copper what is obtaining with this, it is going to be 99.9% pure. So it is a very pure copper you will get from electrorefining. Okay, and the next application of this electrolysis is electroplating. that also derived from this particular way, you know, like we are keeping a anode and cathode, and we will see how that electroplating, how it is going to happen. Okay, so see, electroplating, we will see what is happening. See, sometimes, no, this automobile vehicles, sometimes some of the utensils, some of the stuffs and all, that is going to be, you know, like okay. So you think that you are having a spoon. It is easily corroding because it is made with the steel, or like it could be made with the steel. Okay, and so this is a spoon, and think that, you know, this is a solution of, okay, silver nitrate. So this is connected to battery. Okay, and here the anode, you will be taking silver as the anode. Okay, what shall happen here when you are taking silver as the anode, and you know, when the electricity passes, so we will see what will happen, and from that we will tell you I can tell you the applications. See, in the anode, Ag plus electrons. Okay, and this Ag plus, it will pass, it will go to cathode. Okay, so this is a cathode. It is actually a you know, this is actually a spoon, which is in fact it is steel. It is made with the steel. So this silver, it will just slightly coat. It will slightly coat on the surface of a spoon. Okay. Okay, it is slightly coated on the surface of spoon, and the spoon, it is getting coated with the, you know, silver. Okay, and so that is the situation. Now you know, yeah. So what is the reality is, you know, like in anode, you know, it is silver. So the spoon, you know, it is having some small thickness. When small thickness of silver, they will just switch off the battery, and electrode deposition will be happening. So initially the spoon, you can see the spoon. So it is actually you know, normally looking with the steel. And once after silver coated, you see how is the appearance. It is a very silvery appearance, right? It is looking good. So this is called electroplating. So whatever the metal we want to coat, we will keep it in the anode. So instead of silver, you can keep tin, you can keep gold, you can keep copper, and what we want to coat, we will keep in the cathode. Okay, because in the cathode only, the cathode, actually what reaction is happening? Cathode, you know, cathode reduction is happening. So Ag plus, it accept an electron, you know, like it is going to be Ag. So this reaction is going to happen there, right? So this is the reality. And when we use electroplating, in the time of, you know, when during automobiles and for preventing corrosion. Suppose if something is corroding, you know, you have to coat it with a tin or something. Okay, and so that get you know, like that will be completely, you know, coated with that particular element. Okay, so this is going to happen. These are the things, you know, it is going to happen in the case of electroplating. Through the electroplating, you know, like you know, so that spoon or anything, it will be, you know, like it will be covered with that particular metal. Okay, so this is the thing. So this application is actually nothing but electroplating. It is also called the corrosion. It prevents in corrosion. It also help you with the decorative applications. So for example, you know, certain ornaments, certain utensils, certain things, you know, it will be coated with the gold. Only the outer surface will be gold. When we look, you know, it will look like, okay, gold, very good, it is gold. Okay, but actually it is not gold. Internally it is another metal. Okay, and for ornamental applications, for this preventing corrosion and different similar applications, we commonly uses electroplating as one of the method. Okay. Wow. So wonderful applications of electrolysis, right? Okay. So this is the beauty of electrolytic techniques. Of course, there are much more to say. Electrocatalysis, electrochemical synthesis, electrochemical senses, different and lot of applications are there. Okay. Yeah. We will see those in higher classes. Okay.